The Big Bang. It's how our universe started. Before this, many scientists believed the universe was infinite and had no beginning. But things changed with Einstein's theory of relativity and Hubble's discovery. They found galaxies moving apart, just as predicted. In 1964, scientists found cosmic background radiation by accident. This was evidence from the early universe. It helped make the Big Bang the main theory. New technology, like the Hubble telescope, has shown us more about the Big Bang and our universe. Recent data even suggests the universe is expanding faster. So how did the Big Bang happen? How did everything come from nothing? Let's dive in. The Big Bang wasn't an explosion. It was space itself stretching everywhere, all at once. The universe began as a tiny, dense point. In a fraction of a second, it expanded rapidly to about the size of a football. This expansion wasn't into anything. Space itself was expanding. Imagine blowing up a balloon. The surface represents space, expanding as you blow. Unlike the balloon, the universe has no edge or outside. It is everything. This can be hard to grasp because we are used to boundaries. In cosmology, the universe includes all that exists, so there's no outside to expand into. This initial phase set the stage for everything that followed. Clearing up this misconception helps us understand our place in the cosmos. The universe's expansion is still happening today, explaining why distant galaxies move away from us. They aren't traveling through space. Space itself is stretching, carrying galaxies along. This idea is crucial for understanding the universe's origin and evolution. In the beginning, the universe was incredibly hot and dense. Temperatures were so high that energy transformed into particles, which existed briefly before annihilating each other, releasing more energy. Gluons created pairs of quarks, fundamental particles that form protons and neutrons. These quark pairs often destroyed each other, but sometimes produced more gluons, continuing the cycle. Matter and energy were almost the same at this stage. Matter began to win over antimatter, with a tiny excess of matter remaining. This leftover matter forms the universe today. As the universe expanded and cooled, forces like electromagnetism and the strong nuclear force started acting separately. The universe had grown to 1 billion kilometers across. Quarks formed stable combinations, creating protons and neutrons. Some combinations of quarks were unstable, but a few persisted, forming the building blocks of atoms. This period set the stage for the matter that fills our universe now. In just 1 second, the universe had expanded to 100 billion kilometers wide. It was still incredibly hot, but it began to cool enough for neutrons to start turning into protons. The first simple atoms, mainly hydrogen, began to form. Imagine the universe at this time as a hot, dense soup filled with particles and energy. This soup was incredibly thick and chaotic. But as it cooled, things started to settle down. Protons and neutrons, known as hadrons, combine with electrons to form atoms. This process created a stable, electrically neutral environment. This period is often called the Dark Age because there were no stars yet, and hydrogen gas was dense enough to block visible light. So, even though there was energy in the form of light, it couldn't travel far. However, there was no life yet to perceive this light. During this time, the universe was cooling rapidly. The temperature dropped from billions of degrees to a few thousand degrees over a short period. This cooling allowed atoms to form and remain stable. The universe was transforming from a chaotic, hot mess into a more structured and stable environment. This phase was crucial because it set the stage for the formation of more complex structures, like stars and galaxies, which would come later. As the universe continued to cool, hydrogen gas started to clump together under the force of gravity. These clumps of gas formed the first stars and galaxies. The formation of stars was a critical step because stars are the engines that produce heavier elements. Inside stars, hydrogen atoms fuse together to form helium and other heavier elements through nuclear fusion. This process releases a tremendous amount of energy, which we see as starlight. As stars formed, their intense radiation began to affect the surrounding hydrogen gas. This radiation was strong enough to break apart the hydrogen atoms, turning them into plasma. Plasma is a state of matter where electrons are free from their nuclei, and it allows light to travel freely through the universe. This period marked the end of the Dark Age. For the first time, the universe was filled with light that could travel across vast distances. The formation of stars and galaxies created a new phase in the universe's development. These structures began to form about a few 100 million years after the Big Bang. Galaxies formed as groups of stars, and their gravitational pull brought them together. Over billions of years, these galaxies evolved into the vast, complex structures we see today. This process of star and galaxy formation continues, shaping the universe and making it a dynamic and ever-changing place. What happened at the very beginning of the Big Bang? This is one of the biggest mysteries in science. Our current understanding of physics breaks down when we try to describe the very first moments of the universe. At this point, the natural laws we know, like gravity and quantum mechanics, don't seem to apply. Time and space as we understand them didn't exist. To solve this mystery, scientists are working to develop a theory that combines Einstein's theory of relativity with quantum mechanics. This unified theory could explain what happened at the Big Bang. There are many questions we still can't answer. Was there a universe before ours? Is our universe the first and only one? What caused the Big Bang? Did it happen naturally according to laws we don't yet understand? These questions are at the forefront of modern physics. Researchers use advanced technology, like particle accelerators and space telescopes, to gather data that might offer clues. Despite these efforts, we may never fully understand the exact moment of the Big Bang. But the pursuit of this knowledge drives scientific discovery and deepens our understanding of the universe. What we do know is that the universe began at the Big Bang and has been expanding and evolving ever since. The Big Bang marks the beginning of our universe. From this event, everything we know emerged: particles, galaxies, stars, planets, and eventually life on Earth. We are made of the same elements created in stars, making us a part of the universe itself. This connection means that by exploring the universe, we are learning about our own origins. Understanding the Big Bang helps us appreciate the incredible journey of the cosmos. From a tiny, hot point to the vast, complex universe we see today. The quest to answer the remaining questions about the Big Bang and the universe's origins will continue to drive scientific discovery. As we learn more, we deepen our connection to the cosmos. So let's keep exploring, asking questions, and seeking to understand the universe until there are no more mysteries left to solve.